In this video, let's practice finding the sum of an arithmetic series and for a geometric series, whose first and last terms are given. Let's first take a look at the arithmetic series on the left. To evaluate the sum of an arithmetic series, recall that we have two formulas. So let's just copy them here. You can see that the first formula requires the first term, a, the common difference, d, and the number of terms, n. If you look at the second formula, it requires the first term, t1, the last term, tn, and the number of terms, n. Since in this series, the first term and the last term are given, the second formula will actually be easier to use. But we still need to determine the value of n. To evaluate n, we need to figure out where this 20th term falls in this sequence. So if this 20th term is the 10th term, that means we have 10 terms in this series. If it's 20th, that means we have 20 terms in this series. How do we figure out which term actually is 20? We know that the general term of an arithmetic sequence is Tn equals to a, which is the first term, plus n minus 1 times the difference d. So we know the first term a equals to 1, then plus n is the value we need to solve, minus 1. So d actually equals to t2 minus t1. t2 is 5 over 4 minus t1 is 1. So d is actually 1/4. You can also subtract the second term from the third term, and the difference is still 1/4. Now we plug in the value into this formula, d equals to 1/4. So for the term whose value is 20, we have 20 equals to 1 plus n minus 1 times 1/4. To solve for n, let's subtract 1 on both sides. This gives us 19 equals to, so 1 minus 1 here is 0. Then we have n minus 1 times 1/4. Then we multiply both sides by 4. 19 times 4 is 76 equals to n minus 1. Therefore, n equals to 77. So now we know that 20 is actually the 77th term, which means there are 77 terms in this series. Now that we know all the values, let's plug them into the second formula. So we have the sum of this arithmetic series as n equals to, n is 77, we have 77 terms, times t1 is 1 plus the last term is 20 divided by 2. So it equals to 77 times 21 divided by 2, which equals to 808.5. Okay, let's move on to the geometric series. To evaluate the sum of a geometric series, we also have two formulas. Let's copy them here as well. You can see that the first equation requires the first term a, the common ratio r here, and the number of terms n in this series. We know the first term a equals to 2, but we still need to determine n and r. Looking at the second formula, we need the first term t1, which is 2, the n plus 1th term, which is the term right after the last one. So the last one is the nth term. And also we need to know the common ratio here. But this formula doesn't require us to find out the number of terms n. We can easily identify the first term, and it's straightforward to figure out the common ratio r and the n plus 1th term, tn plus 1. So this formula will be much easier to use. We can determine the common ratio by dividing the second term by first term, t2 divided by t1, which is T2 is minus 6 and T1 is 2. So the common ratio R is minus 3. For a geometric sequence, we multiply one term with the common ratio to get the next term. So the last term, 13,122, multiply the common ratio, which is minus 3, gives us the n plus 1's term. So we have Tn plus 1 equals to Tn times R. So Tn is 13,122 times negative 3. Then we know the n plus 1's term is minus 39,366. Alright, let's then plug the values into the formula. Using the second formula, we have Sn, the sum, equals to Tn plus 1 is minus 39,366 minus T1, so T1 is 2, divided by R. R is minus 3, then minus 1. This can be simplified to minus 39,368 divided by minus 4. Therefore, the sum of the theories is 9,842. I'm using these two examples to illustrate how to choose the appropriate formula when the first and the last terms are given. For an arithmetic series, you can use either of these two formulas. Both require you to determine the number of terms in the series, so neither is significantly superior. But for a geometric series, using the second formula, we don't need to determine the number of terms. So for a geometric series, the second formula is much easier to use.